In this video, you will learn how to solve polynomial inequalities. So how are we going to solve polynomial inequalities? All we have to do is just rewrite the inequality so that there is a zero on the right side of the inequality, and then we find the critical numbers or the zeros, and then we use those numbers to test, to solve for the solutions. We can either create a sign chart or we plot those points on the number line and then find the set of all values of x for which the inequality is true. So let's solve some problems here. So we're given here x cubed minus x squared minus 20x greater than 0. Okay, solving polynomial inequalities is just similar to solving normal or the standard polynomials. Okay, we can equate this to 0. X cubed minus x squared minus 20x equals 0. Okay, then we'll find the zeros here. We can extract x, or we can factor out x, and we are left with x squared minus x minus 20 equals 0. And then we can factor x squared minus x minus 20. We'll look for factors of 20 that when we multiply them it would equal to negative 20, and then when we add them it would equal to negative 1, because the coefficient of the middle term is negative 1. So that would be 5 and 4. Since the coefficient of the middle term is negative, so that means the larger number should be negative. So this is x minus 5, x plus 4. Therefore, the values for our x are 0. Okay, this one is x equals 5. We add 5 to both sides, and then this one is negative 4. We subtract 4 from both sides. Okay, now we have our critical numbers that we are interested in. So let's try plotting these points on the number line. Okay. So if this is our number line, so we have 0, negative 4, and then 5, negative 1, negative 2, negative 3. 1, 2, 3, say 4, and this is 5. Okay, since our inequality here is greater than 0, that means we look for solutions that are greater than 0 or positive. And it doesn't have an equal sign, so that means these points here, it should be open. In this, on these points here, 0, negative 4, and 5. Okay, and all the way to the right is positive infinity, and to the left. And now we can test the points. So we have 5 regions here. This 1, 2, 3, 4 regions rather. So we have 4 regions, and we test the points. So we test one point between 5 and positive infinity. So let's try 6 here. Okay. We substitute, we plug in 6 to our equation here. Our factors. So 6 positive, 6 minus 5 is positive, and 6 plus 4 is positive. And positive times positive is positive, and positive times positive is positive. So that means this region here is positive. And then for the next one, between 0 and 5, let's try 1. So if it is 1, then we plug in here, it's positive. 1 minus 5 is negative. 1 plus 4 is positive. Then positive times negative is negative. Negative times positive is negative. So this region here is negative. And then we try a point between negative 4 and 1. So let's say negative 4 and 0. Let's say negative 1. So if it's negative, that means this is negative, negative. And negative 1 minus 5 is negative. Negative 1 plus 4 is positive. So negative times negative is positive. Positive times positive is positive. And then we try one point between negative infinity and negative 4. Let's say negative 5. So that would be negative 5 minus 5 is negative, and this negative. Negative times negative is positive. Positive times negative is negative. Since the inequality is greater than, so we are interested in those points that are positive or greater than 0. So those regions that are positive are the regions between negative 4 and 0, and then 5 and infinity. So our graph would look like this. Okay. And then this one here. Therefore, the solutions would be negative 5 and 0 union 5 to positive infinity. So this is the negative 4. This is negative 4. Sorry. Negative 4, 0 union 5 to positive infinity. So this is the interval notation. And then we can also write this as our x, the value for our x will be, values for our x will be in between 0 and negative 4, or x is greater than 5. So these are the solutions to this polynomial inequality here. Okay, let's try another one. Okay, x cubed plus 10x squared plus 21x less than 0. So let's equate this to 0 to find the critical numbers or the points that we will be interested in. So we can factor out x here. So we have x squared plus 10x plus 21 equals 0. And we factor this quadratic equation here. So look for factors of 21. When we add them up, it would equal to positive 21, positive 10, and then when we multiply them, it will equal to positive 21. So this is just x plus 7, x plus 3 equals 0. Therefore, the values of x's would be 0 or negative 7 or negative 3. So we have 3 points here, 0, negative 7, and negative 3. So let's try plotting them on the number line. So this is our number line here. This is positive infinity and negative infinity. This is 0, this is negative 3, and this is negative 7. Okay, since the given inequality here is less than 0, so that means it's open, it's not equal. Now let's test some points. So we have 1, 2, 3, 4 regions here. So let's test some one point between 0 and infinity. Let's say 1. So if we plug in 1 here, 1 plus 7 is positive, 1 plus 3 is positive, so that means this region is positive. And between negative 3 and 0, we can try negative 1. So negative 1, negative 1 plus 7 is positive. negative 1 plus 3 is positive. So negative times positive is negative, negative times positive is negative, so that means this is negative. And then we try one point between negative 7 and negative 3, let's say negative 4. We plug in here, this is negative. Negative 4 plus 7 is positive. Negative 4 plus 3 is negative. So negative times positive is negative, and then negative times negative is positive. Okay, you take note that when the highest degree of the polynomial is odd, then the signs are alternating, whereas when the degree is even, then the sign doesn't change. So let's try one point between negative 7 and negative infinity. So let's say negative 8. So negative 8 is negative. Negative 8 plus 7 is negative. Negative 8 plus 3 is negative. So negative times negative is positive. Positive times negative is negative. Okay, since the inequality is less than 0, so we are interested in those points that are less than 0 or negative. So we are only interested in these ones. Therefore, the solutions would be in between negative 3 and 0, and then 7 to negative infinity. So we can write this in interval notation. That would be negative infinity, negative 7 to negative infinity, union negative 3, 0. Or you can write this as x less than negative 7, or x is between 0 and negative 3. So this is the solution to this problem here. Okay, let's try another one. Okay, what if we're given this one, 2x cubed minus x squared minus 15x plus 18 greater than or equal to 0. Okay, in this case, we cannot factor the polynomial. We cannot factor this by grouping. So we use the rational as 0. We look for the factors of the last term and the leading term, or the coefficient of the leading term. Will be p over q. Factors of 18 are 1, 2, 3, 6, 9, 18. And then factors of the leading coefficient are 1 and 2. So we look for one possible 0 here, and then we can use synthetic division to solve for the rest of the zeros. Okay, so we try 1. It will be 2 times 1 cubed minus 1 squared minus 15 times 1 plus 18 equals 0. We'll see if this is equal to 0. This is negative 1, 15 plus 18 equals 0. So this is 1 not equal to 0. Therefore, 1 is not one of the zeros, rational zeros of this. So let's try 2. So 2 cubed minus 2 squared minus 15 times 2 plus 18 equals 0. So 2 times 8 minus 4 minus 30 plus 18 equals 0. 16 minus 4, 30 plus 18 equals 0. Okay, so this is 0 equals 0. Therefore, 2 is one of the zeros of this, one of the critical points. So x is equal to 2. And now we can solve the rest of the zeros by using the synthetic division. So that would be 2. We have 2, negative 1, negative 15, 18. Then 2 times 2 is 4. Negative 1 plus 4 is 3. 6, and this is negative 9. Negative 9 times 2 is negative 18. So this is 0. And then our equation would be 2x squared plus 3x minus 9. Then we can factor this by AC method. So we'll look for factors of 9. That will be 3 and 3. So this is just negative 3, 2x minus 3 times x plus 3. Therefore, the other points would be 2x minus 3 equals 0. Then x here is 3 halves. And the other one is x plus 3 equals 0. So this is negative 3. So the points, the critical points that we are interested in are 2, 3 halves, or negative 3. 3 halves is 1.5. So let's plot these points on the number line. Okay, 2, 3 halves, and then negative 3. So if this is our number line, let's say this is 0, 1, 2. So 3 halves is 1.5. It should be here. 3 halves, and then negative 3. Okay, since our inequality here is greater than or equal to 0, so we have an equal sign here, so that means our graph would be closed. So this is closed here, this one too, and this one. Now let's test points. So we have 1, 2, 3, 4 regions here. So it will be confusing. So let's test one point between 2 and positive infinity. Let's say 3. So let's plug in the points here. So when x is 3, this would be positive. 3 minus 1.5 is positive. Therefore, this region here is positive. And then we try point between 2 and 1.5. So let's say 1.8. So 1.8, plug in 1.8 here. Minus 2 is negative. Positive. 1.8 minus 1.5 is positive. So this would be negative times positive is negative. Negative times positive is negative. And then we'll try one point between negative 3 and 3 halves. So let's say 0. We plug in 0 here. 0 minus 2, negative. Positive, negative. So negative times positive is negative. Negative times negative is positive. So this region here is positive. And then we try one point between negative 3 and negative infinity. So this is negative 4. We try negative 4. We plug in negative 4 here. Negative 4 minus 2, negative. Negative 4 plus 3 is negative. Negative 4 is negative. So negative times negative is positive. Positive times negative is negative. Since our inequality here is greater than or equal to 0, so that means you are interested in the positive regions. So only this regions here and here. Our graph would look like this, and that one. So the solution of this polynomial inequality here would be from -3, point -3 and 3/2. We use the brackets here because they are included, union to positive infinity, or we can write this as the values for our x would be in between 3/2 and -3. X is greater than or equal to -3, but less than or equal to 3/2, or x is greater than or equal to 2. So these are our solutions here.